new chapter, that is the second chapter of mathematics first. Friends, we know that we use the number system in our day-to-day life or in especially in mathematics. That number system is developed step by step. At first, the counting numbers, that is natural numbers are exist. Those starts from 1, 2, 3 up to infinity. But these natural numbers are insufficient when the same number gets subtracted from it. Means the answer is 0. So that the new concept get developed, and that is the whole numbers. When 0 get added in natural number, then that forms the whole number. These whole numbers are also inadequate when the greater number gets subtracted from the smaller number. For example, 4 minus 8. The answer is not present in the whole numbers. That answer is minus 4. So this is also inadequate. Then the concept of integers get developed, that is natural numbers, opposite of natural numbers and 0, that is the integers. After that, when we divide any two numbers and the answer is in fraction, then the integers also inadequate. Then the new concept gets generated of the number system, that is rational numbers. So what are the rational numbers? If p and q are any two integers and q is not 0, then p upon q. What are the p and q? P and q are integers. P and q are integers, where q is not equals to 0. Then p upon q, p upon q is known as the rational number. It is known as rational number. It is known as the rational number. This is the concept of rational number. The set of rational number is denoted by q. P upon q, P upon q, such that P and Q belongs to I, means integers, and Q is not equals to 0. Then the set of all the numbers is known as the rational numbers. Do you understand, friends? What are the rational numbers? If we take any two integers, suppose those are p and q, where q is not equals to 0, then the form p upon q is known as rational number. This is the rational number which has numerator and denominator. In our day-to-day life we call them, those are the fractions. Okay, do you understand the rational numbers? Now the order relation of rational numbers. Order relation means how we compare them. Suppose P upon Q and P upon Q and R upon S are two rational numbers with Q is not equals to 0 as well as S is not equals to 0. If first condition is that, then P into S equals to Q into R, then P upon Q is equals to R upon S. P upon Q equals to R upon S. Second case, if P into S is greater than Q into R, then P upon Q is greater than R upon S. And third is that P into S is less than Q into R, then P upon Q is less than R upon S. Means we have to multiply them. The cross multiplication is taken. P into S, this is the first multiplication, and Q into R is second multiplication. If both the first multiplication and second multiplication are equal, then the two rational numbers P upon Q and R upon S are equal. If the first product is greater than the second, then the first rational number is greater than the second. If the first product, that is P into S, is less than Q into R, then the first fraction, means rational number P upon Q, is less than R upon S. This is the order relation between the rational numbers. Now we come across the properties of rational numbers. That is, first, additive properties. If A, B and C are any rational numbers, then A plus B equals to B plus A. Means this is known as commutative property. A plus B equals to B plus A. Means the sequence of addition or the number in addition, that is, doesn't matter. 4 plus 3 equals to 7 and 3 plus 4 equals to also 7. This is the commutative property. Second, A plus B, bracket complete, plus C equals to A plus in bracket B plus C are equal. This is known as the associative property. For example, 2 plus 3 plus 2 plus 3 plus 4. 2 plus 3 5, 5 plus 4 9 equals to 2 plus 3 plus 4. 3 plus 4 is 7. 7 plus 2 9. Means we have to add first two numbers and then add the third one, or add last two and then in them we add the first one. The answer is 7. This is known as associative properties. Then additive identity. A plus 0 or 0 plus A equals to A. Means if 0 is added to any rational number, then the answer is that rational number. It is known as additive identity and additive inverse. A plus in bracket minus A equals to 0. Means the addition of a number and its opposite number is 0. Then we come across the another one properties, that is multiplicative relations of rational number. First, A into B equals to B into A. Similarly, this is a commutative property, means 4 into 3 is 12 and 3 into 4 is also 12. Second, A into B bracket complete into C equals to A in bracket A into B bracket complete into C. Means where we take the product of first two numbers and then multiply by the third, or multiply the second and third numbers and then multiply by the first. This is the answer is equal. This is known as the associative property. Then A into 1 equals to 1 into A equals to A. Means when any rational number is multiplied by 1, then the answer is that rational number. For example, 4 into 1 equals to 1 into 4 equals to 4. Means product of 4 into 1 and 1 into 4 also 4. This is the multiplicative identity. A into 1 by A equals to 1 by A into A. Now, the decimal representation of rational numbers. Suppose P upon Q is a rational number where Q is not equals to 0, can be written as P upon Q equals to M plus R upon S, where M is positive, means it is non-negative, and R is greater than or equals to 0 and less than Q. Then M is known as the integral part and R upon S is known as the fractional part. This P upon Q is written as M plus R upon S. M is integral part and R upon S is fractional part of the rational number. The decimal representation of rational numbers is of two types, that is terminating decimal factor and recurring decimal factor. Terminating means when the division, first one is terminating, for example 3 upon 5. When we divide this, 3 is divided by 5, 3 is less than 5, so we take decimal. Now 3 becomes 30, 5 6 are 30. Means the remainder is 0. This division process get completed. Hence it is terminating decimal. And second one is recurring decimal. recurring. For example, 2 upon 3. When we divide this, what happen? 2 upon 3 means 2 is less than 3. Decimal, now it becomes 20. 3 6 are 18. 2 remains. Again take 0, 20. 3 6 are 18. 3 6 are 18. This process get continue. Means it do not have end. Hence, the 6 get repeated after the decimal. So, the 6 is known as recurring. So, the fraction is recurring. And we write this 0. Recurring 6. 0. Recurring 6. In these two.